graph the quadratic function f of x is equal to x squared minus 4x and state the domain and range of the function. So to begin, I'm going to look at the function we were given. F of x is equal to x squared minus 4x. A couple things that I'd like to determine are the x-intercepts and the vertex of the function. For the vertex of the function, I'm going to consider a function in the form f of x is equal to ax squared plus bx plus c. If we have a function in this form, then the vertex of the function is minus b over 2a. And whatever this number is, we'll plug it back into the function and evaluate the function for that number, f of minus b over 2a. So to begin, to start finding the vertex of this function, this is a 1 here, an understood 1. So we have that a is equal to 1 and b is equal to negative 4. So I'd like to find the first coordinate of the vertex. That is the minus b over 2a. So I'm going to substitute in negative 4 for b. So I have the opposite of negative 4 over 2 multiplied by the value of a, which in this case is 1. So two negatives give us a positive over 2, which simplifies to 2. Now, once I have the first coordinate, I'll take that first coordinate and I'll plug it back into the original function. So that is f of x is equal to x squared minus 4x. So I want to plug in a value of 2 here. So I have f of 2 is equal to 2 squared minus 4 times 2. I'm going to follow my order of operations. I'm going to square the 2, which gives us 4 minus 4 times 2. I'll go ahead and multiply here. So that gives us 4 minus 8. And lastly, 4 minus 8 is negative 4. So the vertex of the function given is first coordinate is 2, second coordinate is negative 4. So I'm going to go ahead and graph the vertex. So come over here. The x-coordinate is 2, and then down 1, 2, 3, 4. So here is the vertex of the parabola at 2, negative 4. The next thing I'd like to determine are the x-intercepts of the function. So the x-intercepts are found by letting y be equal to 0. We're taking the function, which is x squared minus 4x, and setting it equal to 0 and finding the values for x. In this case, we have two terms, and we have a greatest common factor of x, which I can factor out. And then I'm left with x minus 4. So x multiplied by x is x squared. X times negative 4 is negative 4x. Next, I'm going to use the zero product rule and set each of those factors equal to 0. So I have x is equal to 0, and x minus 4 is equal to 0. Solving the second simple equation for x, I'll add 4 to both sides and find that x is equal to 4. Thus, the x-intercepts for the function are 0 for x, 0 for y, the origin, and 4 for x, 0 for y. So now I'm going to plot these 2 points. So one of our x-intercepts is the point 0, 0. The second one is 1, 2, 3, 4, 0. The leading coefficient here, a, is 1, And since a is greater than 0, it opens up. The parabola opens up. So our vertex is here. It's also going to pass through these two x-intercepts. It opens up. And here is the graph of the function f of x is equal to x squared minus 4x. We're also asked to state the domain and range. So the domain of a quadratic function is all real numbers. We can plug in anything we want to, as far as real numbers go, into our function. And for the range, I'm going to look at the graph that we just drew. So the graph, I'm going to read that from bottom to top. So the smallest y value I have is the -4, and that point is included on the graph. So I'll use a square bracket at -4, and then the graph is going up forever, so -4 to infinity. That is the graph of the function f of x is equal to x squared minus 4x, along with the domain and range.